Hey guys, I might have discovered or a concept on how to actually time travel forward in time. It just hit me like tons of rocks. I don't know, I was in McDonald's sitting down, and this thing just hit me like a brick, like just an idea on how to travel forward in time, not backwards, forward in time. It's a very interesting concept that I came up with, and it's very, very, very easy. It's not complicated. Extremely easy concept. Anybody can, with the anybody with the normal IQ can actually, if they had the resources, that's a key thing. If they had the resources, they could easily build this. Not home made. Obviously, it has to have a lot of manpower. Maybe with the help of many countries, but the concept's there. It's easy to come up with. Oh, the only problem is it will take a lot of resources. Not a lot. It's just but it's very possible. First of all, let me explain the concept from its beginning. First of all, I gotta for the understanding of how this thing works. Basically, we go to a black hole. And this is a black hole right here. Okay, and if you can see that, you have a spacecraft inside that black hole. Black holes have a extremely strong gravitational force field, or field, and anything inside the field, whether it be a spacecraft, a world, a planet, or anything inside being sucked into the gravitational field, time slows down. The further you go into it, the more it slows down. The more and more it slows down. So the further you get closer and closer to the event horizon, it slows down. So time slows down as you approach the black hole, and the further you go down, it slows down and more and more and more. So that's because of the gravitational field. Time slows down. The stronger it is, the more it slows down. So even if you reach the inside of the black hole, which is called the event horizon, once its spacecraft reaches the event horizon, time stops. That's amazing. I don't know if you knew that, but inside the event horizon, time completely stops. Time is frozen. That's why the event horizon, or the black hole, is called frozen star. That's why it's called frozen star, because once you reach the event horizon, time completely stops. In the entire universe, galaxies and universe as a whole, time stops. This is the only place we know that time stops. Okay, so if you have a spacecraft near the event horizon, but outside, obviously time is slowing down. But if that spacecraft was able to escape out, let's say they were inside for, let's say days. Let's say they were inside for days, and for some reason they were able to escape out. They will realize that everything around them, outside the gravitational fields, outside the normal space and time had already moved forward. Okay, so basically, time around the gravitational field around this is moving at a normal space in time. So let's say you were, in theory, we don't know the exact numbers or calculations. It's just as an example. Let's say you were there for a day, while the normal space-time will be 100 years have passed. So let's say you were stuck in there for a day, but you're able to get out, right? And then you come back to normal space. You realize, oh wow, wait a minute, 100 years have already elapsed. So let's say you're 2019. You go in there and you're stuck for one day, and then you come out 2019, but it's no longer 2019. It's 100 years later into the future. So you already traveled 100 years. It's just an example. We don't know the exact number, but that's a way to make it more easier for you guys to understand. So if you, the more time and the more closer you spend to the event horizon, or outside, obviously, outside, but inside its gravitational field, time slows down. So let's say you stay there a day, and as an example, equals 100 years into the normal space. So if you're stuck in there and you're able to escape, space will be 100 years into the future or so. Like I said, it depends how long you spend inside the gravitational field and how close you are to the event horizon. In other words, how strong they are. Gravitational field, basically, how close you are to a gravitational field, how long you are in a gravitational field, and how strong the gravitational field is. So basically, those are my points right there. Now, how do we build a time machine knowing this fact right here? Very simple. And here's the clue. You need to have, like magnets, this is the south, and this is the north. But inside, you have attraction, and these magnetic gravitational waves, or right here, this is a magnetic field of these two magnets. But these are not two magnets. Let me show you what it is. We have a north and south magnetic fields of the Earth. They're the most powerful of the Earth. Basically, you gotta realize, Earth, as any other planet, bends time and space underneath. This is the space and time blanket underneath. It's like having a blanket, and all the planets. You drop the marbles on top of the blanket, and what happens? You create a dentation in time and space. So all the planets, including the sun, create this little dent right here. This is time and space itself, like a blanket, like a sheet blanket, like in your bedroom blanket, whatever you want to call it. But the marbles make this little dentation. That's what all the planets do. So the weight of it, the gravitational field, does that, because every planet, depending on its mass, creates this dentation of time and space. Well, anyway, we know that the Earth has a north and south magnetic fields. Okay, what if you grab, let's say North Pole, you grab this and you bury this cable, right? This cable of copper or whatever, and then you insulate it. First, this is not insulated. This captures the magnetic fields of the north. Same thing will be on the bottom of the South Pole. Drop copper wire or something that captures the magnetic fields of the Earth, and then throw them into the ocean with cables. And now those cables will be highly insulated, very, very highly insulated, to keep the magnetic fields inside those cables. Now, same here in the south. You do this copper wire into the Antarctica, drop those copper wires to capture the magnetic field of the south. So now you have north and south magnetic fields captured, and then drop the cables, highly insulated, to keep the magnetic fields within the cables so they don't escape the cables. And then drop them into the ocean. And somewhere in between, or somewhere, it doesn't matter where, you have this. The north cable and the south cable. Get them close together, and then there, because magnetic field of the north, magnetic field of the south, to get them close enough. Get them close enough where they start attracting each other, and then you create the gravitational field. See what I'm saying? So when you get the north and the south close enough, when they start attracting each other, that attraction, when it starts getting stronger, depending, you adjust it, the distance, either closer or further, but enough distance where the gravitational field starts getting stronger. So that, you create a bubble right there. This bubble right here, where they're close enough where it starts attracting each other, and then you create that magnetic gravitational field, or it starts pulling each other, but not too close. Anyway, not too close. You don't want them to actually join. You want to avoid that. You want to get it close enough where you have gravitational field and gravitational strength. And because anybody in this bubble, time will slow down. So you walk in, time slows down. You walk out, and time has you're in the future. So you could spend a couple days here. You might be a couple months out into the future. You could spend a month here, and you might be 100 years into the future. So this is a time machine concept. It's very simple to build, but it takes a lot of manpower, a lot of from different countries. This is a real time machine. Okay, basically capture the magnetic field through copper wiring, insulate the copper wire with and to drop them into the ocean, the cables, same deal. South, capture the magnetic field with copper wires, and then insulate it and drop the cables into the ocean. And maybe somewhere in the middle, or it doesn't matter where, you get them close together but not touching. And that space where they start attracting each other, you create a gravitational field, and anybody inside will slow down. And when they come out, they might be a couple months or a couple years into the future. They can only travel forward. They cannot travel backwards. So once you walk into this field, your time slows down. Everything around you is moving fast. But when you come out, you realize you already travel forward in time. So that's my concept of time travel, and this is realistic. This is using hard science. Hard science. It's backed up with hard science. This is totally amazing. This is very exciting. It's very possible that this may actually work. This is more common sense, more realistic point of view of how to build a time machine. The only problem with this is you can only travel forward, and you cannot travel backwards. So that is the only problem with that. But with the same concept, you could also build power. You could design systems that they could generate free electricity. You could also design power plants with the same concept. But for now, we know that that the black hole does that. If the black hole does that, this concept actually will create a time dilation spot where anybody walks in that area, boom, time slows down. When they walk out, they were into the future, days, months, years, or centuries. Who knows? Depending how close these two cables are, that's how intensity increase, how more of a gravitational field increases. The more gravitation increases, the more it slows down. The more it slows down, it means the time travel capacity is more powerful. So you can adjust the time, how far into the future you want to go, by getting these cables closer or apart. And that's how you adjust the time capacity into the future. Anyway, this is a real truth concept. You can research it, but this is my invention on how realistically build a time machine that actually puts you forward in time. And that's using the same concept, exactly the way it works in real life in the gravitational field of outside the event horizon. That's how exactly it works with this concept. So we're taking the exact way it works over here and building our own with the north and south magnetic fields of the Earth. Remember, electricity we have in our house, all those are basically magnetic fields going into the copper wire. People don't realize that. Electricity is magnetic field inside your copper wire. That's the same concept, same principle. Except right now, the most powerful magnetic field we have available close to us, keyword close to us, is the Earth itself, which is the north-south magnetic fields. That's the most powerful magnetic fields we have on close to our fingers, is our own planet. We can use that to our advantage to create a time dilation where we can travel forward in time. The only problem is, once you travel forward, you can't go back. So you might have to say goodbye to your family and loved ones, and because it depends how far you go into the future, you might not see them. So because by then, hundreds of years have passed, and you're probably in the future, and we don't know if the future is going to be pretty or not for humankind. So there you go. You guys have a good one. Amazing facts.